Hello, everybody. Welcome back. Today, I'm going to be talking about compound interest annually specifically. We're going to start talking about this. As a quick review, last time we had talked about simple interest, which is where we're only calculating the interest on the specific principal, not on the interest as well. Whereas with compound interest, we're calculating interest on the principal and past accumulated interest as well. So we talked last time about how the formula for simple interest is I equals PRT, where I is the interest, P is the principal, so our initial amount of money that we're borrowing if we're the borrower, or that we're lending if we're the lender. R is the interest rate that we're charging or being charged, depending if we're the lender or the borrower. And then T is the time in years, right? If somebody borrows money from us for 5 years, they're going to owe us a lot more interest than if they only borrow that money for 5 days. All right, and same thing with if we decide to borrow money from the bank for only 5 days, we're probably going to pay very little in interest. If we have borrowed money for the bank from the bank that we're not paying back for 5 years, we're likely going to owe a lot more interest just because more time has passed, even though the interest rate was the same or the principal was the same. Today, we're going to be talking mainly about this next equation, though. This one is about compound interest. So, A is the accumulated amount. So, for example, the total amount that is being accumulated either in our bank account if the bank is borrowing our money, or the accumulated amount that is accumulating on our credit card balance, for example, if we're borrowing money and not paying the bill on time. 1 plus r, that's because we are going to take the interest rate and add 1 to it, right? The reason we're adding 1 here is because we want to make sure that the interest rate, we're not just calculating the interest, we're also accounting for the fact that we still owe the principal, right? If we multiply any number by 1, we get the same number back, so we're getting that, and plus an additional 8% interest, right? We're not just going to be given interest. Of course, we are also still owed, or we still owe that principal as well. And then n is the number of compounding periods. Right? And so that's the other thing here is that if it's compounded once, then we only get that interest rate once. If it's compounded twice, we get that interest rate twice, right? So depending how many compounding periods there are. For today specifically, we're just going to focus on annually. So we're just going to focus on the compounding period as annually, but in future days, we'll talk about how compound interest can work with other times, right? What if it says that it's compounded monthly? How do we do it then? We're going to talk about that in the future. But for today, we're just going to specifically talk about not that equation, this equation here, with regards to monthly, or sorry, with regards to annually. Cool. All right. There we go. Okay, and here it talks about compound interest. Compound interest means each year the money is in the account, has interest added to the principal money and the interest. So interest earns interest. So for example, let's say the compounding period is annually and I borrowed some money. After the first year, I must pay I'm going to owe a certain amount of interest on the principal. Let's say I decide not to pay that, another year passes. Well, now I'm going to owe interest on the principal and also the interest that I previously owed but never paid, and so on and so forth, right? And so I'm just going to continue to owe more and more and more interest every time because the interest is accumulating not only on the principal that I originally owed, but also the interest because that's considered money I owe as well, even though I never borrowed it per se. It's just a penalty basically for not paying them back in a year or 2 years or however many years, right? Because, years is a very long time to not pay money back. So let's do this example here. It says, find the final amount in a bank account if $1,000 is invested at a rate of 8% for 3 years using compound interest. So let's do that. A is the accumulated amount, so that's what we're seeking to figure out. So A is equal to P, which is the principal, so that's $1,000 for our principal. It's invested at a rate of 8%. So that means that R is equal to 0.08. And then N is equal to 3 because it says that it's being invested, that it's 3 years using compound interest. Now, it doesn't actually specify here that it's annually. However, we're going to assume compounded annually because it does not tell us it's compounded monthly or that it's compounded weekly or that it's compounded every 2 years or something like that. It tells us nothing about that. Now, ideally, in this kind of question, they would tell us it would be better if they clarified that it is meant to be compounded annually. But yes, so that's where we're going to put 3 right there. All right, now I'm going to grab my calculator and let's figure out what this is, and we will go from there. So we're expecting it to be a little bit more than $1,000, basically, because we're investing $1,000. We want to know what's the final amount if we're getting money, right? We're getting this interest for keeping this money there for 3 years, and so it should be more than 1,000. Now, if it's way, way, way more than 1,000, if we get some crazy number like that, we probably have done something wrong because it should be relatively close to 1,000, but still a bit more than 1,000, given the type of question this is. So let's see. So 1.08 to the power of 3 times 1,000 is equal to $1,259.71. Okay, so that's the accumulated amount. So basically, in this 3 years, we have, in this hypothetical scenario, we still have our $1,000 we originally put in the bank that we earned, and we also now have an extra $259.71 that our money earned for us. So that's the correct answer, is that the final amount in the bank account after those 3 years is $1,259.71. Okay, let's try another one. There's 2 more questions here about this. This one says, find the final amount of interest earned if $5,000 is invested at a rate of 15% compounded annually for 6 years. Now, this is a little unrealistic to expect a rate of 15%, but we're going to answer the question anyway. So in this case, A, which is our amount, is equal to P, 1 plus R to the power of N, where P is $5,000. That's the amount we are originally investing. N is 6 because we are compounding 6 times, and the interest rate is 15%, which is the same as 0.15. So again, let's plug our numbers in and let's see what we get. Given how high the interest rate is and the fact that it's more years, I actually do expect this one to be quite a bit more than that original $5,000. So let's see. 5,000, 1 plus 0.15 to the power of 6. So let's see what that is. 0.15 to the power of 6. All right, times 5,000 is going to give us $11,565.30. Now, notice that the question is they wanted to know the final amount of interest earned. Now, A is the final amount accumulated in the bank account. They only want the interest earned. So, in order to find the interest in this case, we must subtract the original principal, right? Because 5,000 of that $11,565.30 is the principal that we originally put in, and then the remainder after that 5,000 was put in is the interest. So the interest is 11,565 and 30 cents minus the original $5,000 we put in will tell us how much the original principal was. So that's going to be, how much the interest accumulated was. And that's going to be $6,565.30, right? Because the amount accumulated here, this is made up of 2 things. It's made up of the principal we put in, and it's also made up of the interest that we're earning just by leaving the money in the bank account. And so anything that's not that $5,000 of principal must be the interest, right? There's only 2 ways that we can get money in our bank account in these scenarios. One is to deposit money. The other one is to earn interest by keeping our money in the bank for a certain amount of time. All right. Very good. Very good. All right, let's take a look at this last one here. It says, how much money would a student put into an account now? So there is $18,000 2 years from now for their first year of post secondary school if the money is invested at a 9% rate compounded annually. Okay, so this student in 2 years from now, so n is going to be 2 because it's compounded annually and this is going to take 2 years, and they would like for the accumulated amount, so the amount in total in 2 years from now, to be $18,000. So that doesn't mean they have to put in $18,000 right now. It means that they want to know how much would they have to put in right now so that in 2 years they would have $18,000. So that means A, the accumulated amount is $18,000, not the principal, right? $18,000 is not what they're putting in the bank account and waiting 2 years for. $18,000 is how much they're going to have at the end of 2 years if they put in some mystery amount now. So P is what we're looking for, right? P is what we do not know, right? We would like to know how much money we must put in. How much must the principal be to get to where we want to go, which is $18,000. And then R is pretty straightforward. R is just the interest rate, which is 0.09. All right, so let's do it. Let's find P. So in this case, we have $18,000 is equal to P times 1.09 to the power of 2. So let's see, 1.09 squared is 1.1881. P is equal to 18,000. So let's divide both by 1.1881 to find out that P is equal to $15,150.24. So therefore, the amount that this post-secondary student, or this soon-to-be post-secondary student, must put into their account today in order to have $18,000 2 years from now is $15,150. So since 2 years isn't really that much time in the grand scheme of things, most of that money they do have to put away now, but they will earn almost $3,000 in interest between now and they put in that $15,000 and 3 years or 2 years from now when they do start post-secondary school. So they will get also some of that money in interest to help them out, which is good. All right, well, that is it for today. For the next day, what we're going to be doing is we're going to talk about calculating the number of payments. Today, we mostly focused on calculating the amount accumulated. We did one where we also talked about how to find the interest specifically by subtracting the principal from the total accumulated. And we also did one where we figured out P, right? Where we figured out what was the original principal if here's the amount we want to have accumulated. What we didn't really talk about is how could we calculate the number of payments or number of years. And we're going to need to use logarithms to do that. So we will talk about that next time because it is a little bit more of a difficult concept. But that is what we will be tackling next time. All right, well, that's it for today. Have a good day, everyone, and I will see you in the next lesson.